Hi there, everyone. Thank you so much for coming to the Arctic Speaker Series for today. And so we're very pleased to have Dr. Sandie Black with us. Dr. Black is the head of veterinary medicine or veterinary services at the Calgary Zoo, where she's been for the past 26 years. And she studied wildlife biology at Acadia University and then did her veterinary medicine studies at the University of Guelph. And today she will be talking about an integrative health index for narwhal in the Canadian Arctic. And so I'll just turn it right over to Dr. Black, and then we'll cover some background stuff, or we'll have a gathering at the Arctic Institute afterwards. You can come up for refreshments and things, and you can talk more with Dr. Black. So please welcome Dr. Black.
Great, thank you. Thank you for coming, everyone. Is that good volume? Great. Well, I'm going to cover a few things today, a little bit of a history of narwhal, because it's the first time I've studied something where the odd person says, are those real? That's really a thing? So obviously there's a lot of history versus fantasy with narwhal. Part of the reason is that narwhal tusks for many centuries were sold as unicorn horns, and they fetched a lot more money with that description than they would have had people in the more southern parts of Europe recognize that they came from a whale and not a mythical beast. So this is from the late 17th century, was about the first time that scientifically the narwhal was talked about in European circles, learned European circles, as actually being an animal that existed. And even at that, we still have sort of a fish-like tail, and in this iteration looks a little bit reptilian. Narwhal tusks were used for many things. They were used to put into drinks to detoxify. The belief was a unicorn horn would detoxify poisons. But they also were used a lot on crowns, and this is the coronation chair of the kings of Denmark that has many narwhal horns as part of its makeup. And they're figuring quite large. Narwhal have a little bit of a cool factor right now. We've got a beer named after them. I'm not going to play it today, but if you just Google narwhal song, it's worth a couple of entertaining minutes with this tagline, "'Cause they are so awesome." And then somebody gave me this toy set a few years ago where strangely a very browny yellow narwhal, and you'll see that that's not an accurate color, has 4 different magical tusks, and it can impale a seal, but also strangely an Antarctic penguin and an Australian koala bear. A little bit about narwhal, just to give you some background. They're a medium-sized toothed whale, so in the way that a bottlenose dolphin would be considered a small-toothed whale, and an orca killer whale would be a large-toothed whale. So they're kind of in between those two. Their closest relative is the beluga. They are considered an apex predator. In other words, they feed on other animals, largely fish and cephalopods. And they are gregarious. So you can see in this picture a group of a dozen or more narwhal. Generally, we see them in groups of 3 to 8. But often those groups are traveling with many, many other groups. So there'll be a superpod loosely aggregated of several hundred animals. And when they're passing by in the summertime, when they're closer to shore, it can take an hour or 2 for the entire group to pass a fixed point on the shore. Length, when they're born, they're just over 1 meter long. The ones that we work on, the mature females are 3.5 to 4 meters. The mature males more like 4 to 4.5. And in terms of weight, females, I don't get to weigh them, but females probably around 900 kilograms. The males up to a metric ton and a half. Age at maturity, we think that the females sexually mature a little bit younger than the males, somewhere in the 5 to 6-year-old range. Males probably not till they're 8 or 9. And in terms of lifespan, again, not something we have a lot of information on, but the color of these animals changes over time. When they're born, they're a uniform. They look very much like a baby beluga. They're sort of a uniform pinky gray, and they look a little bit like a swimming sausage. The younger animals are a dusky gray, and they start to get a little bit mottled, but the typical coloration of an adult animal is white on the bottom and then this speckled mixture, and I will have a picture shortly that shows you a close-up of the skin, of black, gray, and white blotches. But as they get older, much like hair in humans, the white-gray color comes to predominate, and some older males look almost white. They could be mistaken for a beluga, save for the tusk. Gestation, we think somewhere in the 14 to 15 month range. They breed in the spring and give birth the following summer. And just again, to give you an impression of size, just a comparison between a swimming human and a somewhat cartoonish narwhal. In terms of the name, so here is a close-up of the skin. You can see this mottled pattern, and that's very, very typical. Narwhal, a couple of different places that may have come from. Most of the people that I work with follow the idea that nar is a word that represents corpse in Norwegian, and narwhal then would be corpse whale, with the idea that this mottled skin is similar to the patchy-looking skin of a drowned corpse. However, other people feel that, and maybe this is a nicer thing to think about, nara in Old Germanic means narrow, and the tusk is a narrow structure. So that could be the other place that narwhal comes from. Like for many things in their world, the Inuit have many words for narwhal. The most typical one, tugalik, is for an adult male and just means tusked animal or tusked whale. And this is often what you see. This is a tusking behavior that they do when they're at rest. We're not sure necessarily why. It seems to be somewhat ceremonial, but the males are very, very careful with that tusk. They don't like it to touch anything, and so they'll be very careful when they're doing this type of behavior not to contact each other. In terms of how many narwhal we have, IUCN for many years listed these as data deficient. It is difficult in an animal. This is the most northerly, of all the whales, living between 70 and 80 degrees of latitude for the most part. And so they're difficult to count. They spend a lot of the year in very remote, deep water, iced-in areas. So summertime is really the only time to get a good census, which is done by fixed-wing aircraft counts generally. Now they've been listed as near threatened, and it's partly because the populations in general are fairly small. We believe there's about 80,000 animals across the eastern Arctic, but about 70 of those are in the Canadian high Arctic. And so Canada bears a large responsibility for this species, having the bulk of them in our waters. So range, the population that I work on is this North Baffin population, and it is probably around 60,000 animals. So this is by far the largest population of narwhal in the world. What I've shown here is the waters that they spend the summer in. However, they are a deep water whale. They do not like coming into shallow water like beluga will. And so when they come inshore into fjords, they're looking for very deep water fjords to be in. In the wintertime, they move offshore into Davis Strait, into open water there. Second Canadian population in northern Hudson's Bay, probably numbers about 5,000 animals. And the last Canadian population, which we know very little about, despite spending the last 3 summers trying to tag some of these whales, we saw them in total over 3 summer field seasons about 7 times, and we never captured one. We believe this population to be somewhere between 1,000 and 5,000 animals, and it's unclear, because we've not been able to tag any, whether this population is a shared resource with Greenland. We do know through tagging studies that the Canadian narwhal that occupy North Baffin Island are not the same stock as these narwhal that occupy Western Greenland. So while they do mix in the wintertime or are found in the same areas of Davis Strait, they do appear to be discrete populations. And then the last populations, again, this West Greenland, East Greenland, around Svalbard, Franz Josef Land, and then along the northern coasts of the Nordic countries and Russia. But altogether, those populations may number only 10,000 animals. Narwhal adults have no teeth other than the tusk. So while they do have some embryonic teeth, None of those become used teeth in the adult. The only teeth that you can find in them remain either the erupted tusk or an unerupted tusk in the mandible. Probably an undifferentiated tooth. It's either incisor or canine, but really probably not differentiated to that degree. It does erupt right through the lip. It doesn't come out the mouth. Generally in males, it's the left tusk that erupts and then twists to the left. In a very small number of whales, both tusks will erupt, so one on the left and one in the right, but the right one still spirals to the left. And again, scientists aren't really sure why, whether that's something about how they move through the water or something deeper in the animal causing that spiral. About 5% of females will erupt a tusk. It's generally smaller, but seeing a tusk is not a guarantee that that animal is a male. And this would be a tusk on a probably 3 to 4 year old male, so a very, very short tusk. It can grow to greater than 2 meters in length. So this is a picture of a double-tusked male. The tusk itself, there have been scientific controversies recently about the function of the tusk. So while it's been generally thought to be a secondary sex characteristic because it only exists in the male, if it has a survival purpose, then you would think it would be something that would be required in both sexes. However, this gentleman, Martin Nuia, is a dentist from Harvard, has been doing some studies on the tusk and has some early data that would indicate that tusk, like our teeth, has quite an important or quite a strong sensing capacity, particularly for temperature. But what they react to most strongly is salinity. So these whales do not like when a higher salinity water is, when their tusk is bathed in a higher salinity water. And the theory would be that when ice is forming, it's forming as fresh water. And so the remaining water left behind has an increasing salinity. So that would be a signal to the whale that the ice is forming and they need to keep moving out of that area. So that as yet is an untested theory. Many narwhal scientists are not convinced at all that that's the case, but it's sure some interesting work. So if I can play this for you. This is just a video of some narwhal swimming this summer, one of the 2 times that we saw them. This is a pod of females and young. And you can just see some little, there, that's a baby coming up there. So very typical pod in size. They can swim very, very fast, but often they are moving quite slowly through the water like that. And I can't really talk about the narwhal without talking about the people that depend on them. So Canada's Inuit, particularly in the eastern Arctic, are very reliant on the narwhal as one of the food sources for communities, as one of their cultural activities. I know certainly in Pond Inlet and Arctic Bay, 2 of the communities that I know the most people in, it's a very, very anticipated event when the narwhal are either at the flow edge or in the open water in the, later in the summer, and they can go and hunt them. So it's also somewhere where I've gotten a lot of my research samples from, is working with hunters on hunted narwhal. And sometimes it's a difficult thing for us in the south, the whole idea of whaling, but remembering that this has been a reliance that's existed for centuries. So just to give you an impression of the length, this is a younger male narwhal, but the length of the tusk. So this was a summer hunt, and then just a picture from one of the springtime hunts, spring, early summer, at the melting edge of the ice over the open water. So just to take you through a year for narwhal, springtime is when they are breeding. They're moving towards the shore, and breeding activity is occurring. And this, I love this print. This is Scoresby, a Danish explorer and naturalist. And this was some of the first real strong descriptions of narwhal from the early 19th century. In the summer, they've moved right in close to shore, or they're moving along the north shore of Baffin Island and into fjords. So they'll feed strongly at the flow edge, and as that ice retreats, then they're moving into fjords. That is a safe place, for the most part, for the females to give birth. They're not feeding heavily once the flow edge has retreated, but we do find some food in the stomachs of whales that we have necropsied. And this is the time when they're giving birth as well. So you will see females, if you spend time on shore watching these large pods go by, you'll see females stop and just log at the surface. And my presumption, you can't see what's happening underwater, as she swims away, you'll often see a calf, is that she's stopping to nurse. So it's a sensitive time of year for them when they're in these fjords, and many of the females will have a small calf that side. There are some dangers in the fjords, and I was lucky enough to work with a shark researcher over the last couple of summers. We weren't as busy with narwhal, but we helped him with his Greenland shark tagging. Whoops, let me just back up there. So this is the release of one of those sharks. Turn that down. So we were working anywhere from 5.5 feet to 7 feet, these large sharks. And you will see wherever narwhal are being hunted, certainly Greenland sharks come around. They're also seen, if there's an ice entrapment, often there'll be Greenland sharks in the area. So they seem to be very cued into when there's a potential for narwhal as feed. And we have seen narwhal with scars that look like they may be shark bites. Just so you can hear a little bit what they sound like. This would be from a hydrophone underwater. So that gives you an impression of most of the different types of vocalizations. And Martin, who recorded that, called it Narwhal Cafe. As he recorded it, there was a large pod in a bay, and they were just swimming about, didn't appear to be feeding at all, just looked like they were sort of socializing. In the fall, they will migrate back out of the fjords and out towards open water in Davis Strait for this North Baffin population. And then in the winter, they're spending time in leads in the pack ice and in the polynyas, the open water areas that stay open year-round. So my involvement with narwhal started in 2004. I was asked to go up on a Fisheries and Oceans tagging camp, research tagging camp. So capturing narwhal to put satellite tags on them to track where they go, and it's part of the census work that Fisheries and Oceans does. So the logistics, many of you are familiar with northern work, taking huge amounts of food and gear into remote locations. So these Ken Borek twin otters are just the ticket for that kind of trip. This is a very not full load. It's the loads that have the big 45-gallon drums of fuel on them that always make me a little nervous. This is a typical deepwater fjord. This one is on opening out into Jones Sound and on the south shore of Ellesmere Island. Sometimes we start in communities and go out into the various camps by boat. Other times we have a camp where there's a known good beach runway where the planes can land and drop us right into the camp. Teams is a real key word here. It takes a lot of people to do this work. It takes us 2 days to set up the camp and a day to take it down. And they are a combination of scientists and helpers from the south, and then an Inuit crew that joins us from whichever local community that we're working with. So again, this is tents here on Kakiak Point, which is in Admiralty Inlet on Baffin Island. And this was the first summer I was up there, and this is August 23rd. This was our camp this past summer on Ellesmere Island, sitting here by the shore on, pulling a blank on the name of that sound. Of course, lots of other visitors to camp. We do have watches for different reasons, and I'll talk about that shortly, but obviously one of them is this is not a fenced camp, so we do have an ongoing watch for polar bear activity. This is a picture from further south, too much vegetation there for the high Arctic, but, and Arctic foxes, which are sometimes very entertaining guests. Generally, we've had very little trouble with polar bears. The odd time we've had to politely ask one to leave, and this was one of those occasions in 2012.
Okay, he's coming our way.
So this was a young bear. He seemed to be completely unaware that we were there. You can hear the gun being pumped there. Seemed to be completely unaware of our presence. So our two captains, so we generally have Jack Orr is the technologist from Fisheries and Oceans that runs the camps, and James was our Inuit captain, and the two of them walked out with guns towards the bear and started yelling at it. And he completely ignored them until they got a little bit closer, and I think they really didn't want to have to fire at this bear, even the warning shots. And the language turned a little bit more colorful, and the voices went up a bit, and all of a sudden the bear's head went up and went, "Oh, okay," and then he ran off down the shore. Luckily. For our tagging, the whales are caught in a stationary net. So the net's 10 meters deep and 50 meters long. So this is just using the Zodiac to set the net. And it has these white floats. So if you can see here, there's a line of white floats along the top of the water. So whenever the net is set, it is watched every moment of every day, 24 hours a day. Of course, we're up there in August. There's a little bit of dusk on Baffin Island. Up on Ellesmere, there's very little dusk at all. It's 24-hour daylight still. And you have to watch those floats continuously. If a whale hits the net, one or more of the floats will go underwater. And so there's a 24-hour watch, 2 people at a time, to keep an eye on the net and also watch for polar bears. So there's a lot of time sitting around watching and then socializing while we do that, and then sometimes barbecuing while we do that. The camps are small. Everyone has their own sleeping tent, and then we have this large insulated and heated tent, so there's always a warm spot to go. We have 2 Zodiacs always ready to go, so they're always in the water, and they're pulled up and down with the tide so that they're close to shore. Everyone basically has their dry suit and all of their equipment ready to go. So if the call goes out for whale in the net, and it will be shouted, and we use an air horn, and then whenever that shout goes out, the call just gets repeated and repeated by everybody, so the response time is quick. So we're generally watching for whales to come by. Sometimes we see them coming. Sometimes we call them stealth narwhal. They just turn up. You don't hear them, you don't see them, and all of a sudden they're off the beach. So here's our line of floats, and if you see anything, sometimes it's this. So that's a narwhal approaching the net. I would say and that is, if that was in the daytime and we had that kind of proximity to the net, people would be getting their dry suits on already. In the night, sometimes you get woken up and come running out of your tent to put your dry suit on. But our response time between the time the whale hits the net and getting the whale to the shore tends to be 4 minutes or less. So it's a very well prepared camp. So this is a little hard to see here. We've got one of the Zodiacs at the net, and the splash there is the narwhal struggling. But what happens is they'll be pulled up beside the boat and restrained, and then the crew left on shore pulls everything in, boat, net, narwhal, all get pulled in at once, and then we disentangle the narwhal at the shore. So it gives you an impression of the size of the whale as we're working on them. So this one has been disentangled from the net, and then we're just using some extra straps to support the weight. But they're kept in the water. Their tail is at the shore side, and the body should still be suspended in the water. What we don't want is that the weight of their body, come down on the bottom. So if the tide's going out, that means somebody's watching, and you're advancing the whale out as the tide goes out. One of the things I do is take blood samples, and this just shows a really nice view of, you can actually see the blood vessels running on the underside of the tail fluke. This is a much smaller, younger whale, and you can see this gray mottled pattern of an immature whale. So what has to happen while we have them in hand is there's a piercing that happens across their dorsal ridge to hold this satellite tag in place. Our tags last upwards of 12 months before they peel off the animal, and they'll give locations daily through that time uploaded to a satellite link. So this is just some tagging work going on. And then during that tagging time, I'm assessing the whale's health as much as I can. So it gets a full physical exam, mostly visual, so looking for wounds, previously existing wounds, or any damage from the net. And then I take bacterial cultures from the blowhole, respiratory rates, heart rates, and a couple of blood samples, one early in handling and one late in handling. So this is just pulling the tail up and then getting a blood sample from those vessels on the underside. And then the whale is released. When I first started doing this work, our handling times were 30 to 40 minutes. Generally now we're down in the 20 to 25 range, so that the effects on the whale are as the least that we can make them. And then just to show you a release.
Okay, let it spin right around. Keep her going.
That's a very old male. And what's happening there, as he feels the water get deeper under him, he's ready to go. And the reason he's not being let go yet is often what they'll do is they can feel that, that new tag on their back. They'll swim out and flip. And we've had a couple just wipe the tag off. It's an awful lot of money to spend to not get anything back. So we try and get them out where that's not going to be a concern. They will often flip and roll and then right themselves, but not actually contact the bottom. So this is what our results look like from the tagging, pardon me. This is Admiralty Inlet, Eclipse Sound, Pond Inlet is here, Arctic Bay is over here. And all of the red lines and numbers are just locations and travel lines in between them from 8, I guess, different narwhal. And the circle here shows you sort of the location of this larger map. So those would be very early locations when the animals are still close to shore. And then as the season goes on, they'll move offshore into the deeper water. So going up and doing this narwhal work, I've become, and watching some of the changes year to year. So the ice conditions have changed just in the 12 years that I've been going up. I've seen permafrost slumping near Pond Inlet that the community says has never happened before. And certainly none of us are strangers to the amount of literature, both in book and scientific format, coming out about changes in the Arctic, climate change in general, and the fact that it is amplified at the poles. So there's many things changing. One is, one measure we look at is the minimum ice extent. So this would be at the time of year, which is generally September, when there's the least amount of pack ice in the Arctic. So the yellow line represents the median numbers between 1979 and 2000. The green is 2005. The red is 2007. And if you look at 2012, it's less than that again. So that's one of many measures that tells us that things are changing in the Arctic. When scientists have looked at different marine species in the Arctic, because narwhal are very specialized, they're very limited in range, they're quite limited in their food items. It's felt that they are one of the species most sensitive to climate change-driven effects. What that looks like, we don't really know. There are many potential threats. One is predators. So orca have always been occasional visitors to the high Arctic. They are now almost annual visitors. They're there almost every year. And we do know that they have a massive effect on narwhal. One year, in 2009, we tagged narwhal and tagged beluga. A different team tagged, orca. A different team tagged orca at the same time. And someone has looked at the location returns and the rate of movement of both those species in that period where they were both occupying Admiralty Inlet. While the orca were there, the narwhal's movement pattern was very quick, and they never really stopped. So the time that they were spending feeding and resting was very, very little, and it lined up perfectly with the time the orca were in the inlet. When the orca left the inlet, the pattern of movement for the narwhal changed completely. They moved more slowly. They would stop and socialize and presumably feed. So they are very affected by the presence of the orca, and the orca are extremely efficient narwhal predators. Other cetaceans and disease. As Atlantic water moves north, as the temperature of the water changes, it is possible that the pilot whales, which are resident off the east coast of Canada, may move their range northwards. And there are, particularly morbillivirus, a viral disease which is endemic in the pilot whales, is something that narwhal, we know by doing serology, narwhal are naive to. So this could be a very serious situation if those two species become sympatric in the future. Certainly changing ice phenology. Narwhal rely on patterns, seasonal patterns of ice, both for their safety as an air-breathing mammal, to know where it's safe for them to be, as well as for feeding. The feeding of the very, very rich accumulations of food at the flow edge are a very important food source for those animals and time of year for feeding. There are a couple of papers that that theorize that the number of ice entrapments is increasing. This is something that's been known for centuries, that sometimes narwhal are just in the wrong place at the wrong time, and they get caught by the freezing ice. In Greenland, they call this savsat. In the Canadian Eastern Arctic, they call it sikujausimaujut. But it can be hundreds of narwhal. So there have been 2 in recent years, one in 2008, one in 2015, of narwhal very close to Pond Inlet. I haven't heard the final numbers on the second, but the first entrapment was close to 700 whales were entrapped and then humanely harvested by the community. Their option is to be harvested or to drown when that hole finally fills in. And there have been entrapments in areas that have not been recorded before. That seem to be a new event. In terms of the food chain, lots of things happening in the Arctic. How this will play out for narwhal, we don't know yet, but certainly changes in the pH level of ocean waters, the stratification and the saline layers in the water, which may change where some of the plankton are found. Water temperatures are on the increase. Plankton size is on the decrease, and that may have an effect on the prey species of narwhal. And a mismatch of timing, so that plankton blooms are happening earlier, but they're happening before the reproductive time of animals that depend on them for their own reproduction. Huge under ice algae production as we have less snow cover over ice and more sun going through. So just changing the productivity levels of different parts of the ocean. And then locations of Arctic cod. So Arctic cod are an incredibly important food source for many animals in the Arctic. And this is just sort of a tornado of birds feeding on what is probably a cod ball. I just shot this with my phone this summer. Sorry, it's very loud. You can see there's the massive feeding here happening. And we saw this several times. There were harp seals in this fjord the whole time we were there. Starnes Fjord, there we go. Huge numbers of harp seals feeding. The narwhal were in there, and then this bird feeding. And at times we would see just masses of Arctic cod almost right up on the shore. So again, a very, very rich feeding source. Shipping increasing massively in Arctic waters. And when we look at some of these projected numbers of ships going through, if you look at this area here, that is exactly the area where the largest concentrations of narwhal exist. So again, whether that has an effect or not, they are very, very noise sensitive. Resource extraction is another concern. The Mary River iron ore mine is going in central Baffin, and the traffic in and out of that mine, for the most part, while the mine's been being built, has gone in and out through Milne Inlet, which is a primary narwhal nursery area. And then Arctic fisheries, still very, very small, but there are active fisheries both for halibut and Arctic char. Now, char is not a narwhal food source, but it is just more boat traffic, more disturbance in sensitive areas. And hunting pressure. Narwhal are co-managed between fisheries and oceans and local communities. In general, I feel, in my observation, has been that quotas are reasonable for the population. But that can change. There can be political drivers in both directions for numbers hunted. So when we think about the narwhal and their responses to this, my question has become, is there something here we can measure? Can we look at whether the changes in the Arctic are having a negative effect on narwhal? Is it causing them stress? When stress gets high enough, it becomes distress and can cause health impacts. So are there any ways that we can measure this in narwhal over time? Can we find candidate biomarkers to assess those changes, both across time and across a population? So many health measures we use are measures of individual health, and how do we look at those across a population? One of the things we can look to is Inuit traditional ecological knowledge. So again, these are people who've existed with narwhal for centuries and have some really interesting insights into narwhal. And sometimes, I think very usefully, can take us out of our scientific brain. This is a picture of a parasite inside narwhal lung. They have numbers of parasites, and one of the places you see a lot of nematodes is in their inner ear. It's something that the Inuit are aware of, and one of the elders from Grise Fjord asked me, why are those worms there? Which is not something we necessarily ask scientifically. Why are they there? You know, what are they doing there? What effect are they having on the animal? We would look at that, really, worms in your ears, that to us would be a disease. That would be something you wouldn't want. To the Inuit, one of the things that they have noticed very correctly is that younger whales have much higher numbers of worms in their ears than older whales do. And they say they're there to make the whale pay attention. So if you live in an environment where there's polar bears and Greenland sharks and ice that might form over your head and dangerous water conditions, you better be paying attention. And if you're younger and less experienced, maybe you need more reminders to pay attention. It's a completely different way of looking at it. So I hope to do traditional knowledge interviews in 4 communities that all hunt the North Baffin narwhal. So Resolute Bay here on Cornwallis Island, Arctic Bay, Pond Inlet, and Clyde River on the north coast of Baffin Island. And talk to them about, what makes for a good hunt? What changes do you see year to year? What changes have you seen over your lifetime? If you are seeing changes with narwhal, do those line up at all with other changes that you've been observing? Do you go to the flow edge at the same time every year? Has that been steady, or is that something that's changing year by year? And the same with the land-based hunts. Are those happening at the same time? So lots and lots of information I think we can pull, and I would expect that things will come out of those interviews that I haven't considered as yet. We certainly have lots of conventional measures of health we can use. We've done numbers of necropsies of hunted whales, just looking overall at health. What can we find? We found a couple of incidental tumors, but just interesting that this high Arctic, somewhat pristine species still deals with cancer. We can look at disease serology, and we have, using blood samples from the tagged whales, we've looked at avian influenza, morbillivirus, toxoplasma, and a number of other diseases to see if there's something that narwhal have contacted yet. We can look at population indices, so observations of reproductive rates as well as the census counts. Toxin loads, there's a lot of information in the Fisheries and Oceans Gray literature on toxin loads. Parasite burdens, again, mostly from necropsies. So we have these more conventional measures of health. But then what I have accumulated to date, and I hope to add to this sample set, is a collection of samples of blubber and skin. So these are taken by hunters and turned into fisheries and oceans over the years. So we have some samples going back to 1982 and a few right through the 1980s and the 1990s, and then larger numbers through the 2000s. So we're looking at males only who should summer to summer be more comparable to each other, adult males, whereas a female may be pregnant one summer, lactating one summer, and have an older calf in a third summer. So her stress level, if you will, or her health measures may differ more from year to year. I have this star here because this sample set from 2008 is actually from the ice entrapped whales. So this is going to form a positive stress control for the other samples. These are whales that would have been caught in the ice for 1 to 3 weeks before sampling. So with blubber and skin, what are things that we can look at? And one of the reasons to choose blubber and skin is it's something you could collect from a live whale in a biopsy. So it's something that would be very easy to replicate in a fairly non-invasive way. We can look at stress hormone levels in blubber. And this is something that's been done in beluga and harbor porpoise. So quite a bit of work has been done to develop some of these techniques. And we're assuming an inverse relationship between health and stress hormones. As your stress hormones go up, often indices of health will go down. We're using the superficial layer because that's where we can standardize our sampling the most and extracting them in methanol. And I just think it's fun to point out that this is with Kathy Wynne Edwards' lab over at the vet school. She trialed our techniques with butter and bacon because we're using a cold extraction. As soon as blubber warms up to room temperature, it turns to oil, or a lot of it does. And so we're doing it very, very cold so that the blubber stays solid the whole time. So they worked with frozen butter and bacon to trial our techniques. So we can look at those stress hormones, again, over time, between 1982 and 2013 to date. We can also look at proteins in the skin that are associated with stress, proteins that are expressed through stress-related activities, things related to the hypothalamic pituitary axis, proteins related to oxidative stress, to heat shock, those types of things. So this is an antibody-based microarray, and it's been developed initially for bears, use in bears, but it's now also been validated for bottlenose dolphins, which are a fairly close relative of narwhal. So it should be a technique that works very well for us and has now been validated for over 40 stress-associated proteins in the skin. So again, we'll look at this measure across time. And finally, skin-associated bacterial core communities. This is something that's very, a lot of work going on in the human world right now. Our skin is an interface between us and the environment. And everyone has a core skin bacterial community. What Amy April has done, and it's with her lab that we'll be doing this work, is looked at about 56 humpback whales, and she showed differences in that core skin bacterial community when whales are feeding and when they're not, and also large differences between healthy whales and whales in conditions of poor health, whether they were entangled in a net or cast on a beach. So this is another thing that may serve as a health index that we will look at across time. And it's a genomic technique for looking for those bacterial communities. So if we find changes in our parameters, we'd like to know how these relate to measurements of change in the environment, if they relate. and all the sorts of things we've talked about. Shipping activity, ice cover data, harvest levels, water temperatures, predator abundance and presence. I'd love to do prey abundance, but we know very, very little about prey abundance in the areas where I've been working. Frequency of ice entrapment events. And we're looking for changes, but really what we're hoping for is resilience. What I'd love to find is that narwhal, to date, have been resilient to the changes in their environment. So just some quick acknowledgements. A lot of people at Fisheries and Oceans, World Wildlife Fund, many, many other people that have worked in camps, both from the south and the north, and lots of folks in the University of Calgary community, and funding and support partners as well. Thank you. Kuyanami.